This is Jared Broadbent of Arc Solar Systems in Arizona, and this is a video documentation test of the new Votronic MPP 430 solar regulator. A little technical information about the HPS 3000 solar generator before we begin. This generator also has a Votronic MPP 420 that was built into the generator several years ago. The Votronic MPP 420 has virtually identical specifications to the new MPP 430, but it is an older model with a larger housing than the MPP 430. Both Votronic solar controllers are plugged into a Votronic data extender, and you can see the flashing lights indicating they're receiving a signal from both controllers, which is plugged into a Votronic LCD solar computer to read the voltage and output of either the MPP 420 or the MPP 430 independently of one another, or the combined output of both controllers together, depending on which set of solar inputs are receiving solar power, or if both sets are being used. The two solar controllers are wired completely independent of each other with separate wiring to the battery bank and separate solar inputs. We'll be using a 220 amp hour battery bank for this video with two 110 amp hour 12 volt batteries connected in parallel with the batteries in a low state of charge. And finally, we'll be using two independent strings of solar power, each with about 280 watts of power. For the first part of this test, I'll be connecting one string, these MC3 cables with one set of 280 watt solar panels, to the existing Votronic MPP 420 on the rear set of inputs there. We see the immediate rise of voltage with those MC3 connected. As you can see, these are still disconnected. That's the MPP 430's inputs. We have a rise in voltage immediately, 15 amps and 257 watts. Summertime, so we're getting really good solar power here. Okay, so we're seeing the battery voltage rise from 11.9 up to 12.4 almost immediately. So our voltage dropped back down after I unplugged those MC3 cables. We now have no solar power, so I'll be connecting the MC4s, the second string, also 280 watts, and that'll be connected to the MPP 430 through the front set. As you can see, with the front set of MC4s connected, the second string, we have no rise in voltage. No rise in voltage. So for this next part, I'll be disconnecting these MC4s, putting some adapters on them, the second panel set, and connecting them to the MPP 420, the rear set. You can see I put a set of adapters on the MC3. This is the second string that was connected to the MPP 430, the new regulator. It is now connected to the older one. And we see a voltage rise, and 156 watts. We're getting a little bit of clouds right now, so the power's a little diminished. But both sets of panels are working. No problems there. And I'll do the reverse. I'll attach the MC3 connectors with the adapters to the front set, which runs to the new Votronic MPP 430. You can see the rear set has been disconnected, and the MC3 connectors are now connected to the adapters to the front solar inputs, which run to the MPP 430. And as you can see, we have nothing. 0 watts. No rise in voltage. Both voltmeters. Okay, I have both strings of solar panels disconnected. Now we're going to come over to the MPP 430 and take a look here. You can see that the MPP light is flashing every 2 seconds, indicating it is in standby mode and ready to receive solar power. Okay, both sets of solar panels have been disconnected from both solar regulators. We're going to come over here to the MPP 430 and we can see the MPP light flashing every 2 seconds, which is showing proper function. It's showing that it's in standby mode and there's no solar connected. So we've connected the string of solar panels to our solar inputs for the MPP 430, and as you can see, the MPP light has now changed. It's nice and bright and shiny, indicating that it is receiving solar power, indicating that that portion of it is functioning properly. However, again, we show no rise in voltage, 0 watts, solar string connected, with the light on, nice and strong. See, we're testing the battery voltage at the solar controller here, and we have battery voltage 11.6. I've also tested polarity connections to make sure that we're getting a signal through both solar string inputs, and they are working properly, and it wouldn't be otherwise the light wouldn't be on. So the conclusion is this regulator is bad.